Hello students, this is Miss Dalton again. Today we're going to learn about dividing radical expressions. One thing that you need to keep in mind, this is just a rule of algebra, is that simplified fractions have no radicals in the denominator. So if you see a radical in the denominator, that is not simplified. So you need to take it one step further by rationalizing the denominator. So let me talk a little bit about what that is. What you want to do is you want to multiply by 1. Now, in the form of square root over square root. Now, it doesn't have to be square root, it could be cubed root. Whatever radical it is that you have in the denominator, that is what's going to go here. So, both of these radicals are what is in the denominator. Okay. In the previous lesson, we talked about how a radical times itself, it gets rid of the radical. Now, when I say this, it's just the square root that does that. So you have the square root of 2 times the square root of 2, and that's going to be the square root of 4, which in and of itself is 2. So if I take a square root and I multiply it by itself, it will always get rid of the radical. So this is why I'm going to be multiplying by whatever's in the denominator on the top and bottom. And then you're going to just clean it up by simplifying. Okay, so let's look at our first example. We have 2 radical 2 divided by the radical 3. So again, I see I have a radical in the denominator and I cannot have that. That is not simplified. So you're going to multiply the top and the bottom by the radical that is in the denominator. Okay, so let's simplify that. On top now, remember when you multiply radicals, you just multiply the outside. So 2 times 1 would just be 2. And you multiply what's on the inside. Radical 2 times radical 3 is just radical 6. And then it's divided by, well, if you notice, this radical 3, that's going to give me the square root of 9, and the square root of 9 is 3. So whenever you multiply the radical times itself, it gets rid of the radical, so we've got just 3. Now, if I could simplify the numbers that are on the outside of my radical, then I would want to go ahead and simplify those. But 2 and 3, there's nothing that will go into both of those. They don't have common factors, so this is my final answer. 2 radical 6 divided by 3. One other thing I should mention is that radical 6 is simplified, and so this is my final answer. Next example. Let's have you try this one by yourself. And when you're ready to check your answer, you can play back the video and check your answer. Okay, check your answer. See how you did. How did you do? Did you get it right? I hope so. One thing I do want to point out on this one is that radical 35 cannot be simplified any further because you would break it down to be 7 times 5, and those are both prime, and so you wouldn't have a pair, so that one's fine. One mistake that I do see happen quite frequently is they will try and take the 7 and cancel it with this 35 here and make that the square root of 5. Don't do that, though, because it does not work. Notice that the 7 is without a radical and the 35 has a radical. You cannot cancel those unless they are both under the radical. So please don't make that careless mistake. It happens quite frequently, but just be careful. Next example, square root of 2 divided by the square root of 8. I'm going to show you how to work this problem 2 different ways. Let's start with the first way, which would be by rationalizing the denominator. So I'm going to multiply the top and bottom by the square root of 8. So that's going to give you on top, it's going to give you the square root of 16 because 8 times 2 is 16. And on the bottom, the square root of 8 times the square root of 8. That goes ahead and cancels the radical and makes that just 8. The square root of 16 is 4. So I'm going to take that and make it 4 and keep it over 8. But then 4 over 8 will reduce to be 1/2. Okay, now let me show you another way that you could work this problem, and you might have noticed this from the very beginning. What if I went ahead and simplified what is under the radicals from the very beginning? Well, I've got the 2 under a radical and I've got an 8 under a radical. Because they are both under the radical, I can simplify that. 2 and 8 both have a common factor of 2, so I could divide 2 by 2 and make that a 1, and divide 8 by 2 and make that a 4. So here's what I would have. I'd have the square root of 1 over the square root of 4. Well, what's the square root of 1? It's 1. What's the square root of 4? 2. Notice that these two answers are the exact same answer. So, if you notice at the very beginning that you can simplify the radical by canceling, then go ahead and do that. And it saves a little bit of time. You will end up with the same answer. So the answer is 1/2. The next example has 5 divided by radical 10. Now, don't make the mistake of trying to cancel out the 5 and the 10, because one of them has a radical, one of them does not. So we need to go ahead and rationalize the denominator. We're going to multiply the top and the bottom by radical 10. Okay, when we do that, on top we have 5 radical 10. On bottom, radical 10 times radical 10 is just 10. Now notice that we have these numbers on the outside here that can simplify. Both of these have a common factor of 5. So I'm going to take 5 and divide it by 5 and make that a 1, and take 10 and divide it by 5 and make that a 2. My final answer is the square root of 10 over 2. Now, again, don't make the mistake of trying to cancel the 2 into the 10. One of them has a radical, 2 does not. So you cannot cancel those. This is your final answer. On this next example, I want you to try it on your own, and then when you're ready to check your answer, just hit play on the video again. Okay, check your answer. You should have gotten 2 over 3. Hope you got it right. Did you? Okay, good. I went ahead and tried it from the very beginning, going ahead and simplifying those. Both of those can be divided by 2, so I divided 8 by 2 and got 4, divided 18 by 2 and got 9. So that gives me the square root of 4 divided by the square root of 9. Square root of 4 is 2, and the square root of 9 is 3. So there's my answer. Okay, last but not least, our last example says 8 divided by 3 radical 2. One thing that I notice in this example is that the denominator says 3 radical 2. Now, to simplify this fraction, I only have to get rid of my radical. So I'm just going to multiply the top and the bottom by the radical 2, and I'll show you what happens. On top, you're going to have just 8 radical 2. Now, when you multiply radical 2 times radical 2, that equals 2. So you have 3 times 2, which gives you 6. So on the bottom, or in the denominator, I'm going to make that a 6. Now what can I simplify? Well, you can only simplify the numbers that are on the outside of the radical, because again, they have to be like terms in order to simplify. Well, 8 and 6 both have a common factor of 2. If I take 8 and divide it by 2, I get 4. If I take 6 divided by 2, I get 3. Okay? So, it looks like my final answer is going to be 4 radical 2 divided by 3. And there is your final answer. Okay, I hope this lesson was good and that you could understand it. Come to class tomorrow with your notes filled out and your WISC documents submitted, and we will see you tomorrow.